Now let's see what are the applications of total internal refraction. Can you see this? This is a diamond glittering, isn't it? You must have seen the diamond glittering. And now let's understand what makes them glitter. Diamonds have very high refractive index and hence very small critical angle. Any light rays that enter a diamond at an angle greater than its critical angle will undergo total internal reflection. Multiple internal reflections always happen in a diamond, making it sparkle all the time. So you can see the uh, reflections taking place in this diamond. You will observe the light has entered the diamond. It has gone inside. At this surface, it suffered total internal reflection. Again, at this surface, total internal reflection. Again, so it will keep suffering reflections at different surfaces, and ultimately, you will find it to be shining. The second interesting use of total internal reflection is in optical fiber. An optical fiber is a long, thin strand of glass surrounded by glass cladding with low refractive index. Rays of light entering one end of the fiber experience repeated total internal reflection until they emerge at the other end. You can see the diagram of the optical fiber over here. It is shown with the cladding also with low refractive index, and you can observe very nicely that light is entering from here and it is suffering reflection at the various points before it finally comes out. If the light is incident on a cable end with an angle of incidence greater than the critical angle, then the light will remain trapped inside the glass strand. In this way, light travels very quickly down the length of the cable over a very long distance. Optical fibers are commonly used in telecommunications because information can be imported over long distances with minimal loss of data. Another interesting phenomena occurring due to total internal reflection is mirage. What is mirage? Mirage is appearance of finding water. It occurs in the desert region. A person, when moving in the desert, feels that there is a water long away, but that water is never found. So let's see what happens. In a very hot day, normally at desert, the air near the ground is much hotter than the air at higher altitude. Cold air is optically denser than hot air. When light ray travels from the upper part of the air to the lower part, it will be refracted away from the normal and consequently experiences total internal reflection. Now over here, you can see that light is coming from here, and if you assume this to be made up of different layers, so at each surface, the angle of incidence will keep on increasing. Finally, when it reaches over here, the angle of incidence will become greater than the critical angle and the light will suffer total internal reflection before it reaches the person's eye. And here you will see that it appears to be shining and appears to be like water. As a result, a water-like image appears on the surface of the earth, which is known as mirage. Now see, this is a desert region and you can find that there's a light coming from the sun. It is falling on different layers of the atmosphere, and it suffers total internal reflection at this place. And to a person here, there's a camel being shown. If there's a person standing over here, it seems to be shining and it will appear to be like water. This phenomena is known as mirage. Another use of total internal reflection is in endoscopy. What is endoscopy? Technique to see the visual images of internal organs. Endoscopes use optical fibers to produce an image of inside the body. A doctor can insert a bundle of optical fibers into the body. Some carry light into the body and some carry light reflected off internal body surfaces back out. This allows the doctor to see an image of the inside of the body clearly and helps them to diagnose diseases like cancer or see what they are doing during keyhole surgeries. Now, here you can see how the endoscopy is taking place. There's a light traveling from a device entering the body. It suffers reflection and it can be seen through the telescope by the doctor. So these